Hello kids, hope you all are well. Let's discuss today's JEE Mains question paper. As you all know, the chapters which were there for these exams, first is Biomolecule, second is Amines, third one is General Organic Chemistry, which we commonly know it as GOC. The fourth one is Isomerism, fifth one is Nomenclature, and the last is Hydrocarbon. So, let us begin with the first question what you have got on the screen, kid. The first question is like this: in which of the following compounds is hydroxylic proton the most acidic? Now, simply the word indicates acidic, that means we have to discuss over here something called as acidic strength. So, over here what we have done in the lecture, if you remember, over here I am writing it as an acidic strength. Now, there are some groups which affects the acidic strength. So, now there are two types of groups in the nature. One is electron withdrawing group and other one is electron donating group. Now, obviously which group will increase the acidic strength? Obviously it is nothing but an electron withdrawing group which will increase the acidic strength, and electron donating group will decrease the acidic strength. So, now let us see our MCQ. We have got over here in the first example the group is fluorine. In the second example we have got a group is iodine. In the third example the group what we have is fluorine, and in the last example the group what we have got is fluorine. In all these four examples, if you see, we have got functional group which shows -I. But if you see example number D, where you have got a fluorine which will show -I effect as others, but this will show maximum -I effect because it is very close to that OH group. Hence, our correct answer, which is most acidic, has to be the answer D. So, the correct answer is for this MCQ is D. Is it clear? Let us start with the second question, kids. You can see over here the question is, which of the following is not a valid resonance structure of para-amino benzaldehyde? Now, as when you see the term called as not a valid, so if you remember kids, inside the classroom we have discussed, pay attention on a concept called as pentavalency. Now, there are certain elements in a period number 2 which cannot cross octet state. So, here if you see your example D, where you can very clearly see this carbon atom, where it contains of 5 bonds which you can see very clearly, yes, and hence if you see as per the concept, carbon cannot cross and tetravalency. So, here not a valid structure, your correct answer has to be D. So, correct answer for this MCQ is D. Let us proceed to the next question, kids. What you can see now is on the screen the third question. Now, as a third question, what it says, arrange the following compounds in increasing order of polarity, and there are 3 structures given to you. Obviously, the first structure what you can see is nothing but 1, the middle one will be 2 and the last one will be 3. Now, the question comes is, what you can tell about polarity? So, first thing over here the thing is greater the charge separation, greater the charge separation, more is the polarity. Now, you will ask, what do you mean by this? Just wait. I will just take all 3 examples what we have got over here. The first example, child, if you check, I think so what we have is a cyclopropane ring having over here a ketonic group. The second example what we have got is again a cyclopentane ring which contains 2 double bond and having 1 ketone group, and the last one if you see again it is a cyclopropane ring having a double bond and you have a double bond O. Now, these are those 3 examples which I will mark it as first one, this is the second one, and this is the third one. Now, see, as per the concept we know that this pi electron can get shifted over here, Again in this case also the pi bond can get shifted over here. Again in this case your pi bond can get shifted. So let's write the structure what we get. Let's write the structure over here. Now after getting this pi electron delocalized, what will happen? You will get a cyclopropane with an oxygen having a minus charge and a plus charge. Same way in the second example, again that 5-membered ring, what you have got, again here you will have got an oxygen. So electron has got shifted to oxygen, so oxygen will become minus and this will become plus, and you have got even a double bond also in this. Now the last structure, if you see, again it's a cyclopropane type of a ring having one double bond. Now just a pi bond got shifted to an oxygen, so your oxygen will be minus in this case and this will be plus. Now if you pay attention, you will see, sir, everywhere there is a charge separation. So what? Now if you pay attention on the discussion which is next, if you just see what we have in this example, if you see this particular part, what you can see, it's nothing but what? In this particular part, if you see, you have, this is a non-aromatic, it's non-aromatic. Whereas in the second example, if you check, it's an anti-aromatic. And in the last example, if you check, this particular part becomes aromatic. That means now when you see about the stability over here, this will be most stable. I think so anti-aromatic will be the least stable, and the first example will be moderately stable. Now with this, what you can predict? From this we can predict that this particular compound, what is structure number 3, will always try to remain in this form more as stable, whereas in this example number 2, this ion will not try to remain in this form because it is an unstable. So overall, if you see over here, the polarity will be more for the third compound. Yes, your polarity will be for third compound maximum. Then you will have got compound number 1, and then you will have got compound number 2 will be the least polar. But now the question is what? We have to find out, arrange the following compound in increasing order. Now when you talk about increasing order, what we need to do? We have to go from least polar to more polar, correct? So what we have to now do, out of this, the one which is least polar, can I mark that as nothing but structure number 2? Now in the increasing order, the next one will be structure number 1, and then in increasing you will have got structure number 3. So this is nothing but your correct answer. So as per our option key, if you check, as per our answer key, if you check, your option C suits well for this. So the correct answer is C, which I think so you are very clear. So this question you must have seen, we have done in class also. Let's proceed with the next question, what we have, child. Now here this question is comparatively very simple. You can see the IUPAC name of the given compound you have to find. First of all, you should be able to identify over here, this is an amide group, point number 1. Now there are two groups which are attached to an amide, one is bromo and one is chloro. Now obviously these are side chains, so alphabetical order has to be used while writing these names and the prefixes. So B comes first over C, so immediately first of all you can cut down your option C, you can cut down your option D. So your correct option can be either this or your correct option can be either this. But now the next thing, you have to find out first what is that selection of a parent chain. Now when you select a parent chain, it contains how many carbon atom? 2. And whenever you have got 2 carbon atoms, see over here it's 1 carbon atom and here it's a 2 carbon atom. That means your correct answer in this example has to be B. So the correct answer for this MCQ is B. Hope so this example is simple. Let's try it with the next example what we have. Again it's an MCQ and based on a UPSC. Now whenever kids, if you have got this type of example, if you notice there is a carboxylic acid. Now first very important thing, this is a main principal group, point number 1. Second thing, the parent chain in this is cyclopentane. So the next important thing is your acid functional group is not a part of the parent chain. So it has to be written as outside the parent chain. So we have got a different suffix name for outside the parent chain, and I think so that's what, carboxylic acid. So now over here if you see the higher priority group is acid, so it cannot be carbaldehyde. So first option is gets eliminated. Now cyclopentane cannot be the example because acid is a main principal functional group, so it should be the suffix name. So even this option is cancelled. Now only left out with 2 options. One is carboxylic and this is carboxylic. Now what else you can see? While numbering, you know that this will get number 1, this will get number 2, this will get number 3. Now if you see double bonds come at second position. Now out of these 2 examples, you can see your double bond comes at second position. Over here it's not. That means even this question option B is incorrect. Only one option is left out which is correct as per a proper name. So your correct answer is D. Let's proceed with the next question, kid. What we have got on the screen. Now, yes. Now this question is what? Electrolysis of cold concentrated aqueous solution of potassium succinate yields. Now kids, if you remember electrolysis in the entire syllabus of organic chemistry, we have got one answer where you talk about electrolysis, and I think so that's a coal based electrolysis. And point number 2, in a coal based electrolysis, when you do a mechanism, you come to know that free radicals are generated. So let's write this reaction. First of all, the problem is what would be the structure of potassium succinate. Basically we have to take succinic acid. So can I write over here, succinic acid is what, kids? It's nothing but 4 carbon atom dicarboxylic acid. So can I put 1 carbon atom? Can I put a second carbon atom? Over here this is the 3rd carbon atom, this is the 4th carbon atom. Now this is a carboxylic acid you have got over here. Here also you have got a carboxylic acid. Now since they have not given a carboxylic acid, they have given a salt. So I have to remove that acidic H and put a potassium over here, put a potassium over here. Now what will happen? When you have got with this electrolysis, so you need to take 2 molecules of water in this case. And what would happen in this? Let's see the first part. The first thing what you should know is this particular part will get lost out as a carbon dioxide. This also will get lost out as a carbon dioxide. Point number 1. Point number 2, over here your bond will break homolytically. Here also your bond will break homolytically. So what will happen? This electron pair and this electron single will come together and make a pair. So the product in our example will be CH2. Already you have got 1 bond. Now the new bond which will be formed would be a pi bond, and I think so this example what I have got is called as an ethene. And still if you want to know what are the other byproducts, I'll just give you idea. Over here you have got 2 units of carbon dioxide, which is a gas. Now what is left out? I think so you have got 2 potassium part. Obviously it is going to get combined with 2 hydroxy groups. So here you will get nothing but 2 units of KOH and 1 unit of hydrogen gas. So this is the entire balanced chemical reaction, but I think so this is an MCQ where we have already got an answer. I think so your answer is ethene. So the correct answer for this MCQ is B. Is the term clear? Let's proceed with the next question, kids. What we have over here. Now this question says that a mixture of 3 compounds, methane, ethane, okay, Oh, in this question, if you see a mixture of methane, ethylene and acetylene gases are passed through a valve bottle containing ammonical cuprous chloride, the gases which will come out from this bottle would be. Now, first of all, you should know one thing very clearly. I think so in this example number 7, one is given as alkane, one is given as alkene and one is given as alkyne. Now, ammonical cuprous chloride, now you have got one topic called as alkynes where we talk about ammonical cuprous chloride. Now, what is ammonical cuprous chloride? Let us see over here. See, I have taken 3 compounds over here. The first one, I think so it's nothing but a methane, second is ethene. So, I will just take a methane over here. The second compound is ethylene. Ethylene is nothing but alkene, which is ethene. And last compound given to you is acetylene. Now, acetylene is nothing but 2 carbon atom triple bonded compound. It's an acetylene. Now, when you treat this with ammonical cuprous chloride, what will happen? Same way over here also, if you treat it with cuprous chloride, what is going to happen? Now, listen. Out of all this particular 3 examples, what you can see, your alkyne contains an acidic H. And I think so, this ammonical cuprous chloride will react with this molecule called as acetylene to form a red PPT. It will form a red PPT of, if you want, I can give you the structure also of it. It's C triple bond C. Being acidic, it will lose its H, so it will form a negative part. And you will have got copper over here making a salt formation. Same way on this side also you will have minus, and again a copper will form a salt. So, it's nothing but a cuprous salt which has got the red PPT. Whereas in above 2 reaction, no reaction would be there for methane and no reaction would be there for ethene. That means when they are gases, obviously the gases are being passed from a bottle. One is going to get solidified as in a PPT form and the remaining 2 will remain as a gas only, so they will be coming out. So, I think so in this case, who will be remaining in a gaseous form? After the reaction also would be these 2 only which will be in a gas form. Hence, what will come out from the bottle would be a mixture of methane and ethylene. So, the correct answer for our this question is A. I hope this is clear, child. Let's proceed with the next question what we have on the screen. The next question, I think so what you can see is, what is the major dehydration product in the following reaction? Hope I think so you must have understood from the question. This example would be nothing but where it would be a ring expansion, but let's understand that by this example. So, I will do over here, I will take one example which has been there on the screen, as I have got over here a 5-membered ring which you can see clearly, having another one more ring which is 4-membered ring, and having over here OH. Now, what is given on the arrow? I think so on the arrow it is given as H3PO4. Basically, it is an acid. So, can I tell the first step will be protonation? Yes, protonation. So, let us have first step protonation. So, this will take a proton. So, your structure is going to be like this, child. Here, you will have got 4-membered ring. I am just drawing in some little better form. Here, you have got this type of arrangement. It's 4-membered ring and 5-membered ring, and immediate the next carbon atom you have got is something called as OH2, which is plus. Now, what will happen? This will act as a good leaving group and it will leave. So, the structure what you will have is 5-membered ring, correct? Now, what will happen, child? You will have got a 4-membered ring over here, very clear, and you will get a plus charge over here. Now, you must have understood. Do you remember? Here this is a case where 4-membered rings are comparatively less stable. So, here what will happen? Your ring can get expand to get more stable carbocation. and hence here the product obtained would be of this type, child, where this is a 5-membered ring, correct. Here you have got one 4-membered ring which was initially 4, but now it is going to be a 5-membered ring. So instead of joining over here, I will now join over here, correct. So now what you have got, one thing, from here your bond is getting missed. So here you have got a positive charge. So can I write the structure once again with a proper information as like this in a proper way? You have got this type of a structure where it's a 5-membered ring. Another ring is also a 5-membered ring, if you see. And one more thing, you have got, this is called as a bridge carbon atom, child, if you remember, bridge carbon atom. So here you will have got a bridge carbon atom having a positive charge. So now what is the last step? I think so you would have over here one H, because what is the last step? Deprotonation according to a mechanism. So what will happen? This H will go out, this H will go out, and what will happen? This bond will form over here as a pi bond. So you will have got a molecule where you will have got 2 rings, and between them you will have got a double bond. This can be the most probable answer what you can see out of 4. Hence the correct answer key in this case is D. So correct answer is D for this question. So let's, kids, I think hope you are clear with this example. Let's go for the next question what we have. Now the next question is, in which of the following reaction only single isomer of alkene is obtained? Now if you want, we can take the first example. I think so the first example what we have got is A, it's C6H5, CH2, CH2, CH2 and Br, and they have mentioned over here as KOH in alcoholic condition. Now we obviously know that when we talk about alcoholic KOH, it's an elimination. So we try to find out the leaving group. I think so the leaving group over here is Br, correct, and from the immediate next position we will have a loss of H. So you will get nothing but one alkene over here which is C6H5 having CH2, having CH and CH2. Now from both the places one group has been lost, it leads to an elimination. This is an alkene formed and it will be only one single alkene. Is it term clear? Now same way if you go for the second example what we have, the example number B. Now in B I think so you have got what? C6H5, CH2, then you have got CH with Br, and last is again C6H5. Again the concept is same. You have to use the alcoholic KOH condition what is mentioned. Now let's mark this as alpha, and now there is no option available, you have to remove H from here only. So that's a beta. So your leaving group goes out, the product obtained would be C6, CH, CH and C6H5. Since both the groups have been removed from alpha and beta, you will have a pi bond over here formed. Now over here you can see there is one alkene, but this one alkene will be nothing but a mixture of 2 isomers, because this alkene can show geometrical isomerism. So here it will be one cis alkene and other one would be trans. So as per the question, only one single isomer should be obtained. So your correct answer what up till now look like as option A, but in the option B we have got 2 options available, so this is not possible. Same way in this example if you check, this is the leaving group where it's an alpha and immediately the next carbon atom is beta, but in this place you don't have beta hydrogen, so here your elimination is not possible. So here I can put it as no reaction. But now child, some of you may be thinking, sir, can we do carbocation rearrangement? But now you should understand, alcoholic KOH is a strong base, and whenever there is a strong base, it's an E2 mechanism, and whenever there is an E2 mechanism, there is no carbocation formed, hence no reaction, because no beta hydrogen is available. Now let's go for the next one. In case of a D, you can immediately see over here this is a leaving group which I can call it as alpha. Now here there is a beta and here there is a beta. So there are two beta options available. So here also you will not get only one product, you will get more than one product. Hence, as per our question, if you see, this also can't give you a correct answer. This is obviously not showing only elimination reaction. So only one which is left out is A. So the correct answer is for this MCQ is A. I hope, child, this is clear. Let's proceed with the next question what we have. Over here now see, this is the question number 10 where there is a structure given to you where they have given one ring which you can see, which I am writing once again as a cyclic ring. Here you have got a 5-membered ring having a carbonyl group, having over here a nitrogen. Now again this is attached to the another ring, and I will show that ring also properly. Now what I will do is, both the rings what you have got is an benzene ring. Now my question to you is, first of all a child should know benzene likes to undergo which reaction? Benzene likes to undergo electrophilic substitution, a reaction which we even write in the abbreviation form as ARSE reaction. Now when you talk about ARSE reaction, child, you would be knowing one thing very clearly, that which groups are there which enhance the electrophilic substitution reaction for a benzene. So basically I have told you there are two types of groups. One is electron withdrawing group and other one is electron donating group. Now which group will enhance electrophilic substitution, child? Yes, electron donating group will increase the reactivity and electron withdrawing group decreases the reactivity. That means if a benzene is attached to a donating group, it will show easier electrophilic substitution reaction, whereas if it is attached to an electron withdrawing group, it will be not that easy to show the reaction. So in our example, if you check over here, benzene ring, let's mark this as ring A and let's mark this as benzene ring B. Now for a ring A, over here there are two groups. One group is with a carbonyl group and one is CH2. I think so both the groups are involved, and in the ring B, and the group which is immediately attached is a nitrogen. Now the question is very clear, child, that who will do better reaction. Now as such, if you check over here, this group will act as electron withdrawing group. This will act as an electron withdrawing group. Here it acts as an electron donating group. So first of all, out of these two options, I can cut this option, child. This should be proper, but still you have got this side also, and you know that nitrogen contains a lone pair. This nitrogen can show delocalization over here, and I think so this is also electron donating group. But now when you compare this CH2 and this group, here resonance is involved, here hyperconjugation is involved. So this is going to be a strong donating group, and this would be compared as weak donating group for comparison. Hence the substitution will take place on ring number B. Now when it comes on ring B, there are again two options. You must be knowing donating group always gives electrophilic substitution at ortho and para position. Now obviously among ortho and para, probably what has to be a major product? Probably the major product has to be para. So para will be your major product, and this will be a product, but it will be a minor product. Of course, whenever they have asked a question, as per that, if you see, a ring B should have a substitution, this one. So as per the situation, you can see the correct answer in this example has to be C. Here, first of all, they have not shown only the reaction. Here, if you see, this is ortho position, this is meta position, and this is para. And as per our discussion, your para has to be the answer. So your correct answer Correct answer for this MCQ is option B. I hope so, child, this is clear. Let's proceed with the next question what we have kid over here. Now, again what you can see, which of the following would be the least reactive towards bromine? Now, first of all, if you see there are 4 examples, I will just write the structures of those 4 examples. I have got over here a benzene ring containing a methyl group which is nothing but a toluene. The second example is nothing but phenol. So, benzene ring would have OH group over here. Now, next one is benzene itself, and the last one is nitrobenzene. Now, before we start anything else, first of all the question is, do all 4 compounds are nothing but an aromatic compound which contains a benzene? Yes, correct. And we have just now in the previous example we have seen that benzene likes to undergo which reaction? It's an aromatic electrophilic substitution reaction, correct? Now the question is, which groups are there which enhance the electrophilic substitution? It's the donating group, and which will decrease the reactivity, withdrawing group. So let's now start the analyzing which groups are behaving as what. Now methyl group, when it is attached to a benzene, it shows plus H effect. That's mean it's an electron donating group. Now here, OH group when attached to a benzene, again it contains a lone pair, so it will be used as a donating. So this group is electron donating group, and this will be according to plus R. Now in the second example, I think so there is no group, it will show normal factor. Whereas in this case, you have got nitro group, and nitro group shows minus R effect, and nature wise it's an electron withdrawing group. So right now, if you remember, I had mentioned one thing, and what was that? Over here, if I talk about electrophilic substitution reaction, in nature there are 2 types of groups. Yes, one is electron withdrawing group and one is electron donating group. Now one will increase the reactivity, one will decrease the reactivity. You should know which one is increasing. So donating group always increases the reactivity, and withdrawing group always decreases the reactivity. So as per our example, they have asked least reactive. That means your nitrobenzene, what you can see, will not be that reactive with bromine. So the correct answer is D, which you can see very clearly, child. Done? I hope so this is clear. Kids, let's proceed with the next example what we have. I think so on the screen you can see keto-enol tautomerism is observed in. Now I think so, first of all, child, you should know keto-enol tautomerism requires 2 eligibility conditions. And which are those 2 eligibility conditions? The first one, condition, presence of electron withdrawing groups, like we have seen carbonyl group, nitro group, even nitroso group is also possible, etc. And the second condition was more important, presence of alpha H, which should be attached to sp3 carbon, then your tautomerism is possible. Now here in our example, all 4 you can see carbonyl group is there. So your first condition is valid, but we have to check the second condition. And I think so if you see in the second condition, only one example where you can see that this is the functional group, and the next carbon atom is alpha, which is sp3 also in nature wise, sp3 nature wise, and alpha H is also there. So your correct answer has to be B. So correct answer is B for this MCQ. Hope so, child, this is clear. Let's proceed with the next question. What we have, child, on the screen? And I think so this is one of the reaction. Yeah. Let's write the first thing what is given to us. I think so they have given the starting material is ethylamine. Now, how do you write ethylamine? I think so it's a ethyl group. You can write it as C2H5 or you can put it in the open form as ethylamine. Now, what? Now, treat this with nitrous acid. Now, you should know one reaction that whenever aliphatic primary amine reacts with nitrous acid, your NH2 group is going to get converted to an alcohol group. So, this is that conversion what you should know, correct? So, here what is going to be your answer? Your answer is going to be ethyl alcohol. Now, this is nothing but your compound A. Now, what is the second step you have? Yes, it's a treatment with PCl5. Now, what PCl5 will do, bacha? It's a chlorinating agent which will change your OH group to chloro group. So, this is nothing but the next reaction what you have, product, as ethyl alcohol is going to get converted to ethyl chloride. This is nothing but your component or compound number B. Now, what is the last step? I think so that reaction is react this with ammonia. Now, when you start reacting with ammonia, what will happen? Your H and Cl will get lost and the product obtained over here would be CH3, CH2 and NH2, which is nothing but your compound C. And I think so they have asked us as what? It's nothing but the end of the following reaction. What is they have told to find us is C. So, your C can be nothing but as per the option as ethylamine, correct? And hence the correct answer is D in our example. Hope so, kid, this is clear. Let's begin with the next question, kid. What we have got on the screen is MCQ number 14. Thaliamide reacting with KOH gives you A, and then A reacts with N-propyl bromide to give you B, and this B on further hydrolysis gives you C and D. And they have asked you the option as what is the final product C and D. Now, first of all, child, the first important point is thaliamide. Now, how do you write a thaliamide, child? It's nothing but derived from phthalic acid. So, here this is a benzene ring containing over here a carbonyl group. Over here also there is a carbonyl group, and instead of OH, now I will have got an imide linkage. Imide is something called a secondary amide. So, I have got over here this bond. Now, the treatment is with KOH. Now, when you start treating with KOH, what will happen? First initial part, a salt formation can take place. So, what is the product we have? We will have again the same part I will write, where there is a carbonyl group, and here you have got N minus and your K plus as a salt. Now, this is nothing but what is compound A. Now, what? This compound has to be treated with CH3, CH2, CH2 and Br. And I think so alkyl halide likes to undergo nucleophilic substitution. So, this is that nucleophile nitrogen will attack to this particular carbon. This group will go out as a leaving group along with K. So, your KBr is lost, and the product obtained in this case is, this is your thaliamide part, where it's a carbonyl group, having N, and over here, child, you have got N-propyl part attached. Now last step, this is I think so your compound number B. Now what is the last step, child? Carry out hydrolysis of this. Now when you carry out hydrolysis in presence of base, first thing what will happen, your hydrolysis will take place at amide linkage, where you will get OH part over here and H part over here. Again same way, H part over here and OH part over here. So according to this, the product obtained and a byproduct obtained would be of this type. Here you will have an acid form, but in a form of a salt, and since the salt over here base is KOH, it will be a potassium salt. Here also it will be a potassium salt, and the main desired answer would be, I think so, it would be an ethyl amine as the main product. So over here, as per the option key, what you can see, this is nothing but your compound number C, this is your compound number D. Hence the correct answer for our this question would be is D. So correct answer is D for this MCQ. I hope so, child, this is clear. Let's proceed with the next question, child. What is there on the screen? I think so here there's one molecule given to you, and that's nothing but a benzene type of a nucleus, having again a benzene type of a nucleus. Now I'll show you your pi bonds, child, and here you have got NH2 group, correct? Again over here it's a benzene ring. Now what is the first step? I think so you are treating this with NaNO2 plus H2SO4. Now I think so, child, if you remember, this condition is for diazonium salt. So here what will happen, this NH2 group will get modified to a diazonium group. So what are you going to get? You will be getting like this, a benzene ring having a group, again a second benzene ring, correct? I'll just show the bonds properly inside the benzene over here also. Now here you will have got something called as N2 plus group. Now child, what? We know that N2 is a good leaving group, so this will come out. So what are you going to get over here? I think so the group what are you going to get is a benzene ring, which will be connected to a group, and then again a benzene ring is also there, correct? Now I'll show on the bonds properly. Over here the bonds are shown properly, here your bonds are shown properly. Now here you have got a plus charge, and I think so you know that benzene likes to undergo electrophilic substitution. So here this is an electrophile, this will be a nucleophilic part. So this pi bond will go and connect it to this carbon atom. So the structure would look like this, where you have a benzene ring type of a nucleus, this group, again a benzene type of a group. Now what has happened? This bonds are shown as it is, don't change it. Even this bond is also as it is, don't change it. Now what has happened? This bond has got shifted, and over here this has formed the bond. Now because of that, what will happen from here, the bond electron has been lost, so you get a positive charge. Now last step, what is that last step? The last step in this case would be, here you would have one hydrogen, that hydrogen will get lost, and again your aromaticity would be preserved. So here it's again a benzene ring, again you have got over here this group, again a second benzene ring type of a group. Here this is the bond form. So I'll show just a proper bonds over here what you have got, and I think so now if you see the product out of 4, the most probable product for this MCQ is option D. So correct answer is option D. Is it clear, child? I hope so this is clear. Let's proceed with the next question, child, what we have on the screen. Over here, child, the question is like this, that aniline is reacted with bromine water. So let's write the aniline first. I think so this is that aniline unit, benzene ring, containing NH2 is an aniline. Now when you treat this with bromine water, we know that over here your bromination will take place at all three ortho and para positions. So here the product obtained would be, here you have got NH2 group, here you have got Br at ortho, one more at para and one more at another ortho. So the product obtained is 2,4,6 tribromoaniline. Now what they have given, that this compound what you have got is further treated with NaNO2 plus HCl. So here kids, I think so you know that your amine group will get converted to a diazonium salt. So here your answer is going to be benzene ring containing N2 plus Cl minus. Here you will have got one Br group, here you will have got one more Br group, here you will have got one more Br. Now what? This resultant solution is converted to, what? Tetrafluorofluorate. Now what is this concept? If you remember, there is one answer where you treat this compound with fluoroboric acid. What happens? The product what you get is this group what you have got N2 plus. Now here your counter ion will get changed to BF4 minus, and here you will have got bromo, here you will have got bromo, and here you will have got bromo. So now the last step, this compound on subsequent heating, now last step is to heat this compound. Now when you start heating this compound, what will happen? First of all, the product obtained would be of this type, where this is a benzene. You will have over here your N2 gas will get lost. Yes. So first thing, you have got N2 gas lost. Second, from this compound, that is from this anion BF4, BF3 will be a stable compound which will get lost, boron trifluoride. So one fluorine is left out which will connect to over here, and 3 bromines are already to it. Now as per the option given to us, you can see it will have 3 bromines. Now if you see in this example, you have got 1 bromo. If you have got in this example 1 bromo, in this example you have 3 and 3, means first of all we will cut these two options. Now out of these two, you have got fluorine also in the molecule, where you don't see over here. So this is the correct answer key. So correct answer is, what is the correct answer? C is the correct answer. I hope so, child, this is clear. Let's proceed with the next question what we have on the screen. Now here, I think so this is a very simple and factual discussion. Over here, which of the following pair can be distinguished by filling solution? Now if you remember, which all compounds are given to you? If you see, the first example given to you is glucose, the second example given to you is fructose, the next example if you see is given to you is sucrose, the next example given to you is lactose, the next example given to you is maltose, and there is one more example called as mannose. Now I will just do one thing, child. I will take this sucrose over here, correct, and rest of other 3 groups I will put it together. Why I have done this, I will just tell you, which is a very simple thing. I think so nothing else is left out, correct. Now all these compounds are reducing sugars, and sucrose alone is a non-reducing sugar. Now the question comes is, so why you have used this word? Now the question is, so what is reducing and non-reducing? Yes. Now reducing sugars are those sugars which gives Tollens test and Felling's test positive are called as reducing sugars, and the one which do not show this test, means shows negative these tests, are non-reducing. And I think so if you want to distinguish among the pairs, the most appropriate answer has to be B, because one will give Felling's test positive, sucrose will not give Felling's test positive. So by this method, or by this situation, or by this, or you can call it as Felling solution, this pair can be identified well. So correct answer for this MCQ is B. I hope so this is clear. Let's move to the next question what we have. Now here, I think so, this example what you can see, I'll just write it over here as NH2 CHC. Now over here you have got, just to see this, it's a methyl group over here which has to be over here. So I'll just put over here CH3. This is a carbonyl group. It's NH, it's CH2, and it's an acid. Now before you start anything, child, are you able to see over here and peptide bond? Now here, peptide, you must be knowing there are two alpha amino acids joined over here, and I think so both the alpha amino acids you can see over here, there are two given over here everywhere. But now only the thing you need to find out which one is it. So do one thing. If you check in this example, child, if you check in this example, this is one of the unit and this is the another unit. That means these are two alpha amino acids which have been joined, and if you see from the structure, this unit look like as glycine unit and this unit look like as having a methyl as alanine unit. That means this is a combination of alanine and glycine. So first of all, which names are not proper, we'll remove them. So first of all, if you see as per the option key, your option glycine will get cancelled. Yes. Now, sir, how to name this dipeptide? It's very simple. Now, do you know that the right hand side part of the peptide chain has got your C terminal free. C terminal free, whereas the extreme left hand side you will have got N terminal free. Now, while naming a dipeptide, basically we know as per IUPAC, one has to be a parent chain, other has to be a side chain. Now you can see out of these two units of alpha amino acid, which contains a carboxylic acid. I think so glycine contains a carboxylic acid. That means your glycine will be the parent name, and the other alpha amino acid what you have got would be having a prefix name which is called as alanyl as a side chain. So the correct option key for us as per this answer is alanyl glycine. Alanyl glycine is something like this. So here the correct option, your correct answer for this MCQ is D. I hope so it is clear, child. Let's proceed with the next question, child. What do you have? Now here this question is very simple. They have asked total number of basic group in the following form of lysine molecule. Now first of all, basic group, we know one of the very common group is an amino group which is very common. That is NH2 group is a basic group. But one more thing you should know, child, whenever if you have got a carboxylic acid and if a proton from a carboxylic acid is lost, you get a conjugate base. So over here I think so this unit also look like as a conjugate base. Hence this group or this group, both of them can be called as a basic group. Hence what I can say over here is the correct answer key what we have got is 2. That is nothing but the correct answer for this question is C. Let's proceed with the next question, kid. Now here the next question what we have is this one. Now which of the following indicates the presence of 5 hydroxy group present in your glucose? I think so this is a very straightforward question. Presence of 5 hydroxy group in a glucose was detected by an evidence of reaction with acetylation. So here if you check, there is one point where you can see a pentaacetyl derivative of glucose, and I think so this is only the most common reaction. Yes, over here. So the correct answer is for this MCQ is A. I hope so this is clear, child. It's a factual discussion. Let's now proceed to the next question what we have. Now here we have got a question which is numerical based, yes, where you need to write some values. So here what is the question given? P and Q are the numbers of resonating structures of the following 2 molecules. Now basically there are 2 ions and a molecule given to you. You have to just find out the number of resonating structure. Now I think so we have already done this. Yes, let's write. I have got over here a structure given to you like this. Now I have put over here a pi bond, and here it's a plus charge. Now this is a compound P. Now what we know that whenever we do a resonance, yes child, I have told you that skeleton would remain same. So just copy over here these skeletons, yes, and just don't put a positive charge or a pi bond. So first of all we'll do this, we'll remove this pi bond, we'll remove this pi bond, we'll remove this plus charge also and this. So I've just copied the skeleton. Now how your delocalization would take place, child? Let's see. Over here in the first example, is a positive charge alternate to pi bond? Yes, so pi bond will get shifted over here. So what will happen? This bond will get shifted over here. So your new positive charge would get developed over here. Now we have got a lone pair over here, and I think so you know positive charge and a lone pair on adjacent atom is a case of a back bonding. So here this electron also will get delocalized. So the structure would be, here you have got a pi bond, and because of delocalization you have got a pi bond over here, so your plus charge is generated over here, and hence these are resonating structure of the ion given to you, which is nothing but P. So here total in all you have got 3 resonating structures. Now let's take the next example, child. What we have, I think so this is next, which is 5-membered ring containing a sulfur atom. Now when you have got this case, pi bond, correct, having a lone pair over here. Now what I can do is, let's write the first structure at least. Now this is a 5-membered ring. Don't put pi bonds. Now I'll just do one thing. I'll just copy this and write again. I'll copy this and again I'll copy this. So now let's write the resonating structures for this. So first point, is this lone pair alternate to a pi bond? Yes. So here lone becomes pi, pi is going to become lone. So basic structure, don't make this changes, keep it as it is, this as it is. Now you must have seen lone becomes pi, pi becomes lone. Now again the same thing, lone pair will become pi bond is going to become lone pair. So what is the structure? Write this as it is. Now you can see a pi bond over here, and pi bond will now become a lone pair. Again the next resonating, lone pair alternate to pi bond. So lone is going to become a pi and pi is going to become a lone. So the structure will be like this as it is. Now next is this lone becomes pi and pi will become a lone. Now again negative charge is altered to pi bond, so lone pair will become pi bond and pi bond will become a lone pair. So this structures will remain as it is, pi bond, this bond as it is, lone will become pi and pi has become a lone pair. Now last one more structure you can write for this child, one more structure, and that's this one. I have got a 5-membered ring with a sulfur as a group. Now what will happen, your lone pair negative charge is altered to pi bond, so lone pair will become pi bond and pi bond will become lone pair. One thing child, I think so, while writing lone becomes pi, so at that time you should have a plus charge over here, you should have a plus charge over here, you should have plus charge over here, and lone becomes this, so plus charge will get neutralized. So here you will have a pi bond and a pi bond and its required number of electrons. Now question is what? How many structure you are able to see? 6, but if you remember your first and last structure is same. So in this case the total number of structures are 5. That means if this is a compound P, this is a compound Q, the total sum is 3 plus 5, it comes to 8. So your correct answer, yes, in this case is 8. Correct? Sure? So this is the correct numerical value what you should have. Let's proceed with the next question child. Is it I think so clear? Yeah. The next question what we have is, a polyethylene can be produced from calcium carbide according to following sequence, and they have given 2 steps of reaction. The mass of polyethylene which can be produced from 40 kg of calcium carbide is. Now child, this is a comparison problem which you normally relate. Let's see the first part. Calcium carbide is going to give you acetylene. So सबसे पहले what you have to do, calcium carbide molecular mass, I think so, calcium is 40, carbon is 12, so 2 carbon 24, so it is going to be 64 grams of calcium carbide will give. Now acetylene is nothing but having 2 carbon atoms which is 24 and 2 hydrogen, it will be 26. So it will be giving 26 grams of acetylene. Is it term clear? Which is nothing but the molecule. Now that is 64 kgs of calcium carbide will give 26 kg of acetylene unit, which is one and the same. Therefore, now what they have given, 40 kgs of calcium carbide. So I'll take over here, it's a 40 kg of calcium carbide will give how much? It's a simple cross multiplication child, 26 into 40 upon 64. This will give you nothing but kg of acetylene. Now what is the answer for this? Yeah, I think so you can calculate, and this answer would be approximately 16.25 kg. Now this is the mass of this compound what I have got. Now you have to find out the mass of polyethylene. So now again this was the first part, now it will be the second part to calculate. Now what is the second part to calculate? Again you can see acetylene is how much given? Yes. So 26 kgs of acetylene will give. Now what you have to prepare? It's a polyethene. I think so. This is polyethene. There are 2 carbon atoms. So 12 plus 12, 24, and I think so 4, 28 will give 28 kgs of polyethylene. Now, therefore, the amount what you have got, yes, the amount what you have got, 16.25 kgs of acetylene will give is equal to 28 multiply by 16.25 kgs upon 26, and if you will calculate over here, the answer comes to 17.5 kg of polyethylene. So this is that final answer what we have got of this numerical problem. So here the value has to be 17.5 kg. So child, is this clear what I have done? Let's proceed with the next question what we have. Now I think so this question is what? Number of racemic mixture for this particular molecule, which is 4-chloro-2,3 dihydroxypentanol. Now first of all, what is pentanol? It's 5 carbon atom. Can I take it as 1, 2, 3, 4 and 5. Now on the second position you have got 1 hydroxy group. On the third position you have got 1 hydroxy group. On fourth position you have got 1 chlorine and pentanol, aldehyde. So it's the first carbon atom which is aldehyde. Now just put required number of hydrogens everywhere. So here I have done. Now if you check in this molecule, child, how many chiral centers are there? I think so there are 3 chiral centers you can see. So as per the number of stereoisomer, where n is nothing but the number of chiral center, the answer is 2 raised to 3, the answer is 8. So total number of isomers are 8. But what they have told us to find out? They have told us to find out the racemic mixture, and I think so total number of racemic mixture is what? Is total number of optically active isomers divided by 2. So here it will be 8 divided by 2. So your correct answer has to be 4. So in this case, for us, this numerical question, the answer is 4. I hope so this is clear, child. Let's move to the next one, child. I think so they have asked the question of the following amines, how many can give carbylamine test? Now you should know one thing, child. Carbylamine test is shown positive only for primary amine. So carbylamine test is shown positive only by primary amine, correct? And basically how do you write a primary amine? It is NH2 group. Now if you see over here in the above example, you can see NH2 group. You can see NH2 group, it's a primary. Here you can see it's an NH2 group, it's a primary. So here I have got only 3 such examples where you will have a carbylamine test positive. So only 3 primary amines will show carbylamine reaction. I hope so your answer is clear, child. Let's proceed to the last question what we have. Now, child, the question what they have asked is, consider the following structure, and in this, when this molecule is kept in acidic medium, your X and Y position gets protonated readily. What is the sum of X and Y? Now, if you have heard properly, if you keep this molecule in acidic medium, which will get protonated. Now, obviously, base will be a proton acceptor. Now, you indirectly have to find out in this which all them are a basis. So, now here there are probability wise, one option is this one, which is they are marked as 2. But since this is involved in resonance, its basicity will be less. In this case also, example number 4, if you see, it's nothing but a doubly bonded nitrogen containing a lone pair. Over here you have got this also a lone pair, correct? So, there are so many positions highlighted over here. Now, what is the concept? See, lone pair when gets involved in resonance, it will be less basic. So, this option is cut. Over here, the nitrogen where you can see the case number 6 where lone pair is involved in resonance again. So, over here also its basicity is not possible. Over here the example number you can see 4, which can accept a proton very easily, because lone pair present to a doubly bonded nitrogen is more basic. It is not involved in resonance, and over here also this base is also possible. That means I have got 2 positions. One is position number 4 and one is position number 1, and they have asked sum of X and Y. That means there are only 2 options available, and that is why the answer what you are going to get for this will be 5. I hope so this question is clear, child. Yeah. So, here I think so we have cleared all the questions through a video solution. Hope so if you find any difficulty, please come down to a branch and you are free to ask anytime us any question. Thank you very much, child.